Good morning. Today I will be presenting our work on automated essay scoring using large language models. The focus is on enhancing both accuracy and interpretability by aligning linguistic features with rubrics and leveraging transformer-based architecture. Let's go to introduction. Automated essay scoring has been crucial for large-scale, consistent assessment, particularly in educational and testing context. However, traditional models often miss the nuances in human writing, things like tone, coherence, and style, leading to inconsistency scoring. Our goal is to improve AAC by integrating large language models with rubric-driven linguistic features, providing both the better predictions and more transparency. Let's go to the problem statement. The challenge is threefold. We need AAC systems that are accurate, reliable, and interpretable. We propose a hybrid model that combines rubric-aligned features with Distilbert embeddings. To enhance model performance and fairness, we incorporate PCA for dimensionality reduction and robust scaling. Interpretability and fairness aren't side goals. They are a core to the system's credibility. Let's go to the research questions. Our research is driven by three core questions. First, how can we effectively integrate rubric aligned features with contextual embeddings from Distilbert? Second, can we use attention mechanisms and rubric signals to enhance interpretability and trust in the scoring process? And third, do dimensionality reduction and feature scaling contribute to measurable improvements in model accuracy? Let's go to hypothesis.
Hi, this is Afraz. So I'll be guiding you through the hypothesis of our research. So we hypothesize that incorporating rubric-aligned linguistic features combined with distilled BERT embeddings and attention mechanism will significantly improve both accuracy and interpretability of automated essay grading compared to the traditional models. Now I'll talk a little bit about the dataset. The description of the dataset. Our dataset consists of essays from the Kaggle automated essay scoring competition, set 1. For this purpose, we have only used set 1 from the dataset. This dataset is evaluated based on domain-specific scoring rubric, and each essay is scored in the range of 2 to 12. The dataset approximately contains 1800 essays, each accompanied by its respective scores. Features extracted including linguistic components such as sentence length, paragraph structure, grammar usage, rubric-specific vocabulary, passive voice usage, complexity of the language, adjective count, punctuation usage, and average word length, etc.
So when it comes to proposed framework, we had extracted rubric-aligned features such as syntax, semantics, and coherence. And in the step two, we had generated deliberate embedding of essays and applied a PCA and robust scaling, which has merged features for training of regression classification model, which helps to evaluate the scoring for the students. And coming to preliminary results, we had implemented an enhanced hybrid model combining rubric-aligned linguistic features with deliberate transforming embedding. Our preliminary evaluation employed a robust scaling and PCA for dimensionality reduction, which has resulting in the following metrics. Validation mean square error, MES, which is 1.19, and quadratic weighted kappa, QWK, which is 0.6 approximately. These metrics demonstrate a notable improvement over baseline models, confirming our hypothesis. The QWK score indicates substantial agreement between the automated system scoring and human graders, suggesting the model's reliability and potential applicability in the education settings.
Now moving on to the dataset, which is generated from the code or preliminary results. So these are the features that we have generated: transition words, paragraph count, concrete nouns, code reference, etc. These features are derived based on the rubrics that we have considered while training our Distilbert model. And we have only considered the essay for the preliminary results. We have only considered the essay with the score of 12. Now moving on to the code section. So here's the sample code which we ran on our dataset. We use Spacey to extract features. So here's the code: loading the dataset, parsing the rubrics, extracting features, and initializing the rubric Distilbert class. And here's the main function. This entire pipeline is developed by my friend. This is the This is the epoch number, the training loss, and the validation loss. We can observe that the validation loss decreases in each epoch. And this is the plot of epoch versus loss, the training loss and the validation loss. As you can see, the training loss decreases substantially, and so does the validation loss. Now let's move to the demo of the project.
So we created a Gradio Live interface and we added a essay with a score of 6 and we tested that and we got a predicted score of 6.3. So which is approximately close to the actual human score. This is our preliminary results and thank you.